Good afternoon, ladies and gentlemen. It's a great pleasure to present to you data visualization literacy research we perform here at IUB and also the Make-A-Vis user interface. And we have here in the room with us Herr and also Anna Koine from Learning Sciences over in the School of Education. This is a joint project with Katy Pepler's team in the School of Education in the Learning Sciences program. And Kylie is the director of the Creativity Lab over there. As part of today's presentation, we also have a larger team that's actually involved in this research, involving also Brian Kennedy at the Minneapolis Science Museum, Stephen Uzzo at the New York Hall of Science, and Joe Heimlich at COSI, which is 3 hours from here, another children's science museum. And all of us together, we recently got a grant together to study data visualization literacy by scientific means, and to perform research and tool development that advance public understanding of scientific data. And as part of this particular effort, we also conducted a study where we went to 6 different US science museums, and we interviewed more than 1,000 youth and their caregivers. And it turned out very quickly that most US museum goers, those which make it into science museums, actually cannot properly name, read, or interpret data visualizations, which is kind of sad. And it comes down to the fact that most visualizations that people can read resemble those which are shown in the lower left of USA Today, which are basically a pie chart with 2 slices, a bar graph with 3, but maybe not 4 bars. So it's rather low data visualization literacy. And so the big question is, if the bar is so low, how can you ever get it higher? And how can you get it to the points that we are teaching here at Indiana University in Bloomington? And if you are more interested in the study materials and also in the study results themselves, there's a publication on this, and all study materials are online, because it's our hope that actually researchers in Asia, in Europe, and other areas are taking these study materials, translating them, and ultimately running these studies again in other environments. And it's our hope that actually this type of literacy would be higher in other parts of our world. Now, in our world, we define data visualization literacy as the ability to read, make, and explain data visualizations. We believe it requires literacy, so text literacy, the ability to read and write text, because those text pieces oftentimes appear in access labels. There's a title oftentimes in a data visualization. There's text that comes with it. We believe it also requires visual literacy, the ability to find, interpret, evaluate, use, and create images and visuals. And also, of course, data visualization or data literacy, the ability to read, create, and communicate data. So to, for instance, have a data table and know where those records will appear in a scatter plot, for instance. In today's time and age, we believe people need to read and write text, but also they need to read and write data for personal needs, but also for professional work. So here in our lab, we try to help people properly name, classify, and make data visualizations. And this is in the formal science education space. So in the information visualization course, for instance, we showcase and discuss different so-called taxonomies that help students and others name and classify different types of visualizations. There are hundreds of different visualization types out there, and many of them have up to 5 different names. So there's no expert agreed upon standard of how to name these visualizations, which makes it really hard to actually talk about them. Because if you have a Sankey diagram, for instance, and you have to explain to somebody else what that is and how to use it, if you don't really know what a Sankey diagram is, it's rather difficult. Visualizations have been grouped by user insight needs, by task types, by the data to be visualized, by data transformations, by visualization techniques, but also by the visual mapping from the data variables to the visual variables. And then, of course, there are interactivity techniques, which also have been used to group and cluster different types of visualizations, tools, and interfaces. In the visualization frameworks that we promote and teach here, we start with different question types. You have these so-called when, where, what, and with whom questions. And in many cases, you start with a lot of data on the left, and you try to help people do answer very simple questions, such as how do I find my way through data from A to B? How do I find collaborators, friends? How do I watch what my competition is doing? How do I identify trends? And then our business is in identifying these descriptive and predictive models, which are in the black box here, and to help implement easier and easier to use tools, and to ultimately also develop teaching materials which make it even easier for human users to use those tools. We promote a needs-driven workflow design where you start with stakeholder needs, then you read in data, the data that you can acquire with the resources you have, the time you have, the money you have, the compassion you have. Then you analyze that data, you visualize that data. And as you see, visualization is also a 1, 2, 3 step process. So you read in the data, you visualize, you select a visualization type, you then do data overlays, and then you visually encode the data. Ultimately, you deploy your visualization either as a printout or as a large visualization on a large tiled wall. And then you validate and interpret that visualization. And then ultimately you will get to see if you got the right data, or if you want to zoom in somewhere and you need more data in that area. And oftentimes you do this 10 times, 20 times. So it's a very iterative process. And one more reason to speed it up, because oftentimes these workflows are really 12, 13, 14 steps. And if the output of one algorithm isn't compatible with the input of the next algorithm in line, you will have just a lot of extra work, and it will take you forever to make it once through that workflow. And if you have to do it 20 times, that's just lifetime wasted. There are different types of reference systems. As you see here, you can have scatter plots, you can have geo maps, you could have science maps, you could have networks. All these are just different types of base maps, and overlaid on each, you can have proportional symbols, such as those circles, which you saw in those in this visualization. You can have linkages on top. You can also have animations over time. It's just a horizontal transfer. As soon as you realize, oh, it's just circles, area size coded, connected by links, you can have those in a scatter plot, you can have it in a US map, you can have it on a science map, you can have it in a network diagram. The visualization framework also helps you identify different types of insight needs. So in the leftmost column here, you have those which are generally used. You also have different data scale types, different visualization types, different graphic symbol types, graphic variable types, and interaction types. And so if you encounter a new client, a new visualization task, you can go through that table and just check off what you think you will need. And then ideally, there are algorithms behind each of those. So for instance, some of our tools have extensive sets of network analysis and visualization algorithms. So behind visualization types, network layer, there would be 20 different algorithms that you can use to visualize networks. You can then also take each one of those, and you can go into details of where these come from. There's a lot of prior work by pioneers in cartography and statistics and data visualization, which have tried to bring order to all these different types of insight needs and basic task types, as they were also called. And ultimately, the rightmost column in this table shows you what's used in the current visualization framework. You can also take two of these columns and you can cross-tabulate them. And this way you get a much larger table, which is actually even larger. But what you get to see is you have points and lines and areas and surfaces, then also linguistic symbols and symbolic symbols. And going downwards, you have spatial position, X, Y, and sometimes Z. You have retinal, form, and color. But again, you also have textures and you have motion, which you can use to encode data. And this big table just shows you why it is so difficult to actually get from data to a meaningful data visualization, because your space of different choices is actually quite large. And some of the dependencies between those visual encodings have been tested. So we actually know how good human beings are in distinguishing between the distance between two lines versus the size coding of two circles, but many of these visualization types have not been tested before. And so there's actually a little guidance from cognitive science, for instance, on how to use them. There are at least, I don't know, 10 more PhD theses just in that table to really help us understand which ones to pick when. We recently published a paper on data visualization literacy, and this will actually come out beginning of December. So if you're interested in learning more about the theoretical framework that builds on prior work in data literacy, in textual literacy, and also in visual literacy, there's now a paper on that. There are also courses here at IU which teach that framework and help you understand when to use what kind of tool and what kind of visual encoding. And one of them is going to happen in spring 2019, and the other one is going to be in fall 2019. And the scientific visualization will be a new course. So we are looking forward to see the interdependencies, but also the cross synergies between those two courses. Now, coming to today's topic, the Make-A-Vis, that's actually a tool developed for informal science education. And I was told many, many times that in formal education, I can stand in front of you and I can teach to you. I can just have a one-way conversation with you. In the science museum environment, I cannot do this. I cannot stand on the floor and just try to teach to people. All I can do is engage them. And I'm having tough competition because there are really cute furry animals on the left, there are rockets going up on the right, and in the middle is my data visualization. So what can I do that people even come over to my thing and not to the cute fuzzy things and not to the cool exploding things? It's a really tough competition. And all of you which have been in a science museum, you probably realize that after a while you look at one kind of new element, and then after 2 minutes, you look to the next one. And after another 2 minutes, you look to the next one. And in many cases, what we want, we would like them to engage for 10 minutes or maybe even 20 minutes. And it's non-trivial. So the setup we have, and you will get to experience this in a moment, is a run exhibit where two competing opponents here, for instance, two family members, two siblings, in the Minneapolis Science museum setting can run with each other and they can compete with each other. Then the data is captured, so there's a start sensor, an end sensor, so we get to know how much time it took them to get from A to B. We also have some volunteer other information in the beginning of the exhibit start area. And at the very end, they see their own time, but they also get to explore their data in the context of all the other data of all the other runners before them. And so just so that you get to see how that looks like, I have a little video from the Science Museum in Minneapolis set up. You can race against T-Rex also if you want that. And you can also race against mascots or against really famous sport athletes. Now, in our environment, then we capture all that data. So let's assume we have 50, 60, 100 runners in 1 hour on a busy day. Maybe it's raining outside, so the zoo is out, everybody's at the science museum. Now you get to try to find yourself in the data, and you also try to make yourself look good, either by running again, because apparently you were not really fast compared to all the others, or by selecting a data visualization that actually makes you look good. So you have different ways to now mapping data on the left-hand side to the visualizations on the right-hand side. And as you see, this is actually a figure from the proposal. So the data variables have slightly changed on the left-hand side. But ultimately, you have qualitative data variables and you have quantitative data variables. And you have to match the right ones with the right graphic variables. So for instance, color hue is a categorical variable. So if you have a categorical variable on the left-hand side, you should match that one to color hue. Runtime is a quantitative variable, so size works well, x, y axis works very well for that variable. And that seems to be trivial for those of us which are experts, but it's actually really, really hard for those which have never looked at that mapping between data and visualization before. Ultimately, you actually get to drag the column headers over to the axis labels, and you will get to do that in a moment also. And we have a scatter plot and a geomaps that you can do that for. This is a very early interface of what we thought we would be building. The final interface looks a little bit different, but you see the big splashes you're basically making in the data when you arrive and make it over the end line. Now, the data interface we currently have, and that's also in constant evolution, is showing the runners, each with a symbol on the left-hand side. Then their run time in seconds, their height in inches, their favorite activity, age group, and zip code. And so let's see how many of you can identify a qualitative data variable in that table. What's a good qualitative data variable? Yes, point there. Any others?
You consider age group qualitative?
That can be sorted a little bit, so then that makes it quantitative. Yeah, that's a tricky one. I agree. The symbol definitely is another qualitative one. So down here, you also get to see that we try to help a little bit. So size is quantitative, color, hue in this case, is qualitative. And then you just basically drag column headers down to the legend items or to the axis labels. So just like in Tableau, if you have used Tableau before, it's very similar to that. You also have a geomap. And again, if you volunteered your zip code, we can translate this into a geolocation. If you do not volunteer your zip code, then you're not on the map. And that's another important insight for those which we try to engage in a museum settings, that if you don't volunteer, if there's missing data, there will be an incomplete data visualization. Now, all this code is thanks to Bruce's team on GitHub. So you can actually explore that also. And again, it's under heavy development, but ultimately also we had the exhibit at Make-A-Vis here in Bloomington, Indiana. And there is another video there, which I wanted to share with you because it's a slightly different setup and also different audience from what we will have today.
Exhibit based on Minnesota's sportsology exhibit, and so they put in their information, they run across here, run across our runway, and then they can see their data on the interactive display we created. Yeah. Beat your time.
And look, I got a star. Not everybody gets a star. Some people, they get triangles. I don't like triangles. So I got that star. Look, it's pulsating because I'm still active on here. I have now time in seconds versus age group, but I don't really care about the age group. So let's do the height instead. So let's drag height over here. I want to know if the height people are really faster or not. Hey, this actually works.
Run too fast, it doesn't pick it up. So So you have to run fast and then slow down at the end. Yeah, working out the kinks.
I had a sore knee.
I know. I was running into the door. Actually, this is also for those which don't get to run today, because I see Tassie, I don't think she's here. She's not going to get to run. So this is what you're missing, Tassie, just to say. We also won't have this today, so I'm sorry. Oh, all right. So as part of this project, we are also pleased to have learning sciences researchers on the team, and Anna is one of the team members. Kylie is coming in tomorrow. She gets to run tomorrow for the first time. And as part of this, they are interested to see in how far we can use this exhibit to engage people in learning about data visualization literacy. And also, do they learn anything, or do they just have fun? There are lots of exhibits on museum floors which are just a lot of fun, and that's good too. But what we really, really want is that they actually get to learn more about that mapping between the data variables and the visual variables, not showing them the entire big table, but a subset of it, and not showing them a huge table like what happens in my world, where I have tables with 200 columns, but instead they get a table with 6 columns. So that's maybe more sane. But what Anne is doing is to look at the data visualization literature framework and see how we can, in different stages, introduce that to museum visitors and then test what works and what doesn't work. And in phase 2, they would conduct in-depth qualitative research on the nature of data visualization learning in the context of the RUN exhibit. And it's wonderful for us to have an independent observer, which is not totally in love with the visualization framework, but is actually giving us very bold feedback of, hey, that doesn't work at all as you thought it would. But at the same time, also having a general audience, not us experts, where we surround ourselves typically with students, postdocs, staff, faculty, which are very much interested in data visualization, and therefore they are more experts on that side. But we now have the people on the museum floor, and from that baseline study, which you might remember from the very beginning, we know that most of them can't even read a network. They cannot read a kind of proportional symbol map. So how to engage them and how to get them to read these types of data visualization. Both of them, Kylie and Anne, are also very interested in personalization. So how do you get personal data into the data set ultimately? And they're interested in construction. So not just reading a data visualization, but really making one. And you could argue, well, there are many, many opportunities on a museum floor to read visualizations, but there are actually not so many to make data visualizations. And so that's the novelty of what we are trying to do here. And so on Anne's side, she is now in a very detail-oriented way mapping all the different data types we have to all the graphic variable types that are possible in this simple visualization. And she is doing this for the scatter graph and for the map, and very systematically testing what works and what doesn't work. Our overall goal ultimately is to further refine and also validate this framework, which I introduced in the beginning. We are very interested in hands-on, very constructivist learning environments where people don't just get to listen to things, but get to make things, and with their own body, with their full body ideally. Also in environments which support personalization, because the initial tests and user studies we did showed very clearly that if people have some kind of relationship to the data that they are looking at, they are much more interested to actually explore it. If they can compare themselves to their family members, if they can see themselves in the context of all the other runners, much more interesting than if they get to see the data of 200 athletes. Not so interesting. And also throwing in a T-Rex here and there is not too bad. It's actually helpful. Then we are interested to develop software and then deploy it widely. Ideally, it would also become part of what can be used in formal science education, but that's a little bit further out, even though we are currently actually developing a very similar interface for the new visual analytics certificate, and that's an executive education certificate. So we are actually kind of supporting, funding the development of the Make-A-Vis interface out of a NSF project and out of a teaching project, because it takes a lot of money to implement this in a scalable way. But we are also then using science museums, such as the New York Hall of Science, COSI, and SMM, as a way to disseminate these tools to a large audience. You might know that the New York Hall of Science, for instance, they have 2,000 students each day. Multiple school buses arrive every day, and so you have a huge reach if you get it in these environments. And of course, then ultimately, ideally, it would just be a Canvas plugin. You can just download it, and whenever you need better color theory or better visualization skills for a course, you could just add that in there. If you kind of step back from all of this, then this type of data visualization literacy is really as important as some other types of literacy. We are really interested to communicate and promote better collaboration, communication, to empower people to understand their world better, to interpret election results, to interpret their own bank account statements, to interpret health records by themselves. I mean, many of us actually now have all kinds of data feeds about our own health and fitness, including Fitbits, etc. And we need to make more data-driven decisions in our personal lives, but also in our professional lives. So if we can help that a little bit, that would be wonderful. So now we come to you. So we have set up just for you a run exhibit. So Andreas was so kind to test it. He is the gentleman right here. Leonard, who has worked on the interface, is providing guidance on where the knee should be and not be, so that you're really fast out. And as you see, this is a US run exhibit, so it's just like 10 meters long. It's not 100 meters long, even though we could do that in the hallway, but I guess we would run into people. So if you want to follow us, then please do come over and run, and then see yourself in the data. And Anne also has all kinds of interesting questions for you. And if there are questions, I can answer them now. So if there are questions on the framework or on the setup or on the project, but otherwise we can also do Q&A over when you run, because there is only room for one person to run right now. And we don't have a T-Rex, sorry for that. Any questions right now?
The exhibit with the race in Minnesota, was that existing before?
Yeah. Yeah. So we looked at different ways that we can gather data from people, and one idea was to have a jumping box. So you have a box with a pressure sensor, and you just jump as quickly as you can for 1 minute. And if you have a family, guess who is winning? It's probably the shorter ones, right? Because they can just bounce. They're just more bouncy, I would say. So that was one option. Then there were all kinds of other options, but the run exhibit ultimately won, and we are now focusing on this one. And then ideally, our toolkit would be modular enough that you can also instrument a jumping box, that you can also instrument some other ways how people can gather their own data. Like for instance, another interesting one that came up was a scale that doesn't show you how heavy you are, but it shows you how much blood you have in your system by filling up a tube with red liquid. It's because apparently you can't show people their weight. That's not proper in a museum setting, and other people could see it, oh my God. But showing them how much blood is in their system is actually kind of informative. Any other questions?
Ultimately, would you hope this research feeds into, like, elementary school and high school curriculums, where you could feed this into? I mean, where would you like to see the results of research feed?
So right now, if you look at the lifespan, so I think the average life expectancy in the US is about 80 now. It will be there by the time more people are born. So you have a lot of kind of K through 12 education. Then you have a little bit of undergrad, graduate, but typically with 24 or so, you're done. So after 1 quarter, you're done. The other 75, well, 55 years, technology is advancing very fast. Data sets are just amassing, and the technologies we now have to do high performance computing on large data sets with really interesting new ways to visualize data is advancing also very fast. So we need a way after you're done with your official schooling to keep you up to date. So science museums, libraries are excellent environments where you can engage people in this kind of activity, especially if it's fun. So bringing this to science fairs, bringing it to Make-Ventions, etc., because it has this IoT component, is actually a good way to bring it to many. But then you might also be familiar with some of the phone apps that you can use to, for instance, optimize your ball throwing activity. So you just videotape yourself, you see the trajectory of the ball you're shooting, and then it tells you, well, do it differently. And so I could very much imagine to connect to these kind of apps and then just show people here, the last 200 throwers, this is what happened. And you're shorter, so probably you have to do that strategy. And if you look into professional sport today, they have cameras and sensors on athletes all over the place. So there's a huge need to analyze that data. And in fact, we will have another, not fashion technology symposium, but an IoT wearables symposium in spring here in the makerspace and in the visualization lab. And that brings together people which do IoT sensors for sport and health applications, and then visualization researchers like ourselves, which are interested to visualize that data in ways so that you can really inform your professional decision making. All right, any other questions? All right, then please do come over and run. And it looks like it's like with formulas, you know, whenever you put a formula in your books and it divides the number of readers into half. And maybe if you ask people to run, it also gets your audience to kind of drop off. But it's actually fun. So it's right over there. So let's go over there and run. Thank you. What's the setup for over there? Do you want to bring the camera? Oh, cool. Okay, wonderful. Okay. Can I disconnect my Zoom or should I leave it? Okay. You can do it slow.
Run it holding the keyboard so that
Okay. All right, so start is here, the end yay line is over there. So again, it's a very short runway. But we need the first one to enter information. And so are you running with the laptops? Yeah. Very good. Height in inches.
5'10".
Huh?
Are you 5'10"?
No, 270, you say?
70
is 5'10".
Yeah, so some kids actually don't know their zip code, so that's an issue. So we are working on having the city, comma,
Run right after
Indiana.
Go, after you already?
Oh, it actually stopped. Very good. Very cool. Very, very cool.
It was much faster than the video this time.
Well, I didn't stop it, so mine kept running, and then Bruce's son came and started to explore the screen, and then my data was gone, and I'm like, oh. So if you know about science, kind of street festivals, I think this is a great thing to show off what engineering can also look like, because some other things look more intimidating. I think this is more of a fun part of it.
So there's no start sensor?
How do you start from?
Yeah, it'll just say 3, 2, 1, go. Or
Oh,
it'll
I see,
say
okay.
Basically, 4 seconds.
Do you want to run? So you have to enter your age group. Yeah, German chocolate. Yeah, so we are trying to get it down to $200 because there are lots of small, very, very small science museums which are very interested to have that in their environment. Because basically the average age of kids coming to science museums is like 4.
Oh, okay.
And they have a lot of energy, those kids. So before they ever sit down and explore any kind of data visualization, they would just run their heart out. And then it's some...
Too late. All right, you're really slow. You're really slow. You go. Okay, there you go. So it's a couple $100 plus the
equipment,
and-
yeah.
All right.
So the $200 basically are accounting for the sensors. So everything else science museums typically have. Much faster than Bill, but of course you didn't carry a laptop. Very good. Mm-hmm.
I think I'm an sports shirt. 46076.
I guess it's only counting time. All right, get ready?
No, it's 31 foot. Mm. So we measured it. Whoa, you're the fastest, definitely. Mm. Beat that. Mm. But don't break another leg or your laptop or anything. Yeah.
Hey, Bill, can you step away from the sensor, please? Thank you. I don't know for what reason, but like whenever a sensor like a type.
We need some of this cool music they had behind the videos, you know, with the T-Rex music.
Are you ready?
Oh my God.
2, 1, start.
Okay, very good, very good, very good. Yay! Okay, show us how it's done. Gaming, yeah, totally. He's a gamer.
Switch to the local microphone.
Yeah.
Oh, here comes Dave.
It takes some like getting into.
Look at that.
I'm a triangle.
Sport. So there's a. Okay, maybe that's you. Okay.
So how did you
Okay, so you can interact with
It showed me
the
on the
mouse
screen.
and
Okay.
you
It said,
can actually,
remember, this is your shape.
change
Okay.
stuff around.
Oh, I guess that's because he was
Yeah.
typing things
So
in
you
for
see,
me.
like you can drag and drop things. Thank you.
Yeah, let's see.
So, how are you engaging here?
I tried to see the digital, but I suppose I should go to the left.
Ah, okay. Where would this be on the US map?
It should be somewhere here.
Are you in Indiana?
Yeah.
Okay.
So, what should I do?
Yeah, I don't know. What do you want to do? Maybe you can pick a task.
I don't know.
Yeah.
Compare yourself to other.
Yeah. How would you do that?
I don't know. I will take many people or select many people.
Okay.
I can't select many people.
Ah, okay.
Oh, I appear here.
Is that you?
It seems to be me.
You recognize it because of the zip code, right?
No, because I didn't put the zip code.
You didn't put the zip
Maybe.
code.
Maybe you put.
Maybe Andreas
Maybe you
did.
did.
Oh yeah, maybe you put
Okay.
this one. Okay.
Oh, I see.
That one's me. That one's me.
So okay.
Disclosing information.
Yeah.
Yeah. Okay.
Okay.
What do you like about this exhibit? And you're there too. So how do you compare yourself to others? How would
Poorly.
you phrase it in a positive way?
I took my time.
You took your time. Okay, how can you see that you took it?
So, by the way, that is me. Is the purple.
Oh, the purple
I
is
think,
you.
so I think you're the green.
Are you the green?
So
So-
actually, no, I'm sorry, you're the little triangle. Because I think you came after me.
Yeah.
So where are you then? Here.
So yeah, so I should be. So I'm the
Green
No,
triangle?
I'm the green triangle.
Oh, okay. So you can also.
Wait, I'm the green triangle.
So who's the green? So yeah.
I'm the purple diamond.
I mean, I look at here, and it's defining symbols.
Uh-huh.
I don't know but as you can see, here you're the faster.
Exactly.
For these 4,000 this year, they basically knew where they were at any moment in time. That's creepy, but also you can track all your sheep. And I mean, they were extremely well organized.
You want to sign off?
Hi, thank you for filming.